Alright guys, so welcome back. This is chapter 54 and we are on to part 5. This section just going to take a little bit of a walk around discussing different biogeographical factors and how that geographic location of life really does kind of affect the diversity of a community. And that diversity really gets tied to two major things: geographic location, where is it located on Earth, as well as the size of that particular community and its location. So let's talk a little bit about latitudinal gradients. All right, so remember, latitude goes equator to the North Pole and then down. All right, so we're talking equatorial pole gradients here. And what we find is that your species richness, okay, number of different species you see, biodiversity, if you will, is really concentrated highly at the tropics. All right, so around the equator. And the closer you get to the poles, the less species richness you see. Okay, so it declines as you get towards the poles, increases as you get closer to the tropics. And that really comes from two major factors, sort of just evolutionary history in general, as well as climate. And that's what we're going to take a look at, talk through it in the next couple slides. So if we talk about just evolutionary history, all right, and Darwin was one of the first people to really kind of point this out, is that tropical ecosystem, that climate, that environment, really is sort of the oldest of all environments on the globe. And so that simple just age in and of itself probably has a huge influence on why we see greater species diversity or species richness there. Just the simple fact that they've had time to evolve all of these different organisms. All right. Where you go further out into the temperate and polar communities, and those communities have constantly been sort of stopped and started, if you will, over time by glaciation, ice ages. All right. So glaciers come in, they sort of wipe out what sort of communities have started building there, they retreat, and now those communities have to start all over again. Okay, and so the time expanse for evolution to take place has been kind of truncated, chopped up by those glacier events. Also, the tropics have a much longer growing season. All right, and so biological time, if you will, growth is able to happen quicker. Again, so evolution is able to take place more frequently. There's more of that kind of idea going on. Then you've got your climate. All right, and this is probably also a major contributor here to this different biodiversity. And what you really end up seeing is a connection between the solar energy input and the water availability. All right, and what we're looking at is sort of this connection between diversity and evapotranspiration. All right, so the evaporation of water from the soil plus water from your plants. And you end up seeing much more transpiration going on in the tropics. All right, so there's a constant cycling of water and nutrients. There's a lot of that available to them versus going out into more of the temperate zones and the polar zones. You don't have as much of that cycling of water, and thus you don't have as much of that species richness as a result. So what we can look at then is also the connection between how many species do I have versus the area that I have in that particular environment. And sort of all factors being equal, the bigger the area, the more species you have. And that should make sense. All right. The more space you have, the more nutrients you have available, the more territory, if you're a territorial organism, you potentially have. All right, and so the ability to have more, the more space you have, the more you can have. All right, and so that's really the idea here. And then your text goes into a little bit of this island equilibrium model, which is kind of interesting. And all it's doing is sort of taking both ideas we've kind of talked about already and shoving them into saying, all right, if I've got this island, I'm literally separated from everything else. What sort of equilibrium point is there depending on different factors? Okay, and so it's really trying to explain the species richness on an island having some sort of dynamic equilibrium based on the island size, the distance it has from the mainland, which then also really ties into the amount of immigration that can happen, as well as extinction. And so if we simply take a look at immigration and extinction, all right, there's a dynamic point to the number of species that can live on that island. You start throwing in sizes, all right, the smaller the island size, the lower that number of species is going to be based on extinction. The larger that island size, all right, the further over the more species you can have. Okay. And then the same distance, further away, there's going to be less immigration. It's going to take more energy for an organism to get there, all right, versus an island that's closer. All right, more immigration is going to happen, and so that extinction curve is going to be lower as well. All right, and that's all that really is getting at, is that there's dynamic points for all of those factors that's going to determine the amount of diversity you can see on a given island rather than talking about it on a mainland.